where it means a computer numerical control. A computer is something electronic device that contains CPU, central processing unit, memory, and input and output. A computer can process data and can give information. So when you say a computer numerical control, we mean that the computer, the application software within the computer is helping us to control the machine. And how are they communicating? They are communicating using numerals, digits or numbers, which sends a signal to the drives, the servo drives, the PLC, the sensors, to actualize the machine to move from point A to B. That is what we call CNC machines. There are so many CNC machines. We have what we call the CNC lathe machines. We have the CNC milling machines. We have the CNC router. We have the CNC plasma. We have the CNC laser. All these machines use computers and they use what you call G codes. So I'm going to show you in a simple language how a CNC operates and what it contains. So we have said that CNC is a computer numerical control, where the computer helps us to control the machine using PLC and using numerals. So a CNC now controls what we call a part program. An instruction is coded to control the movement of the machine so that you can cut a part. Remember, part. It means that you cut part by part, then you assemble to get an assembly. So in this part program contains what we call blocks. And these blocks contain words. And in each word we have either an address or a letter. We have numbers or digits, which ranges from 0 to 99999. We have symbols, we have comments. So putting all this together, numbers, address, symbols, comments, forms a word. And many words in a line or in a paragraph or in a block forms blocks. And many blocks forms what? Part program. And a simple example of an address or a letter is A up to Z. CNC machines uses letters or address. An address is where the machine goes, or let's say a store. You have a store, you have a shelf, let's say A, B, C, D, E, F. When you say go and give me a file number A, it will go to address number A and it retrieve the file. So the same way the machines, it knows that this address has a specific number. When you say G00, it goes to address G and then it understands what's the meaning of G. If you say G01, it goes to address G, it has to understand what's the meaning of G1 so that it actualizes the movement. This is an example of address A up to Z. We have A, B, C, D up to Z. We have numbers. Numbers can range from 00 to 99999. So when we write a program, a simple part program can be like this example. Like for this example, let's now look at how these machines operates. Assuming you are using a CNC lathe, what happened with these pens? Assuming you are using CNC lathe, this machine which has a 2 axis, A, XZ, that's meaning the plane is G18. And this is the workpiece we need to cut. This is the workpiece, a simple step turning. So this is a simple step turning. Let's say simple step turning. Assuming this is diameter 40. This is, let's say, diameter 60. This is diameter 80. This length is 40. This length is 60. And this length is 80. The first thing you, as operator, you need to understand is the part origin. Where is the part origin? If you assume the part origin is here, where our X0 is and our Z0 is, it becomes easier for us to program. And for you now to program, once you understand, the first bit you have to understand is the part origin. You need to understand the part positioning. If you look at positioning, you either are using G90 or are using G91. G90 meaning absolute, G91 meaning independent. So out of this, it becomes easier for you to write a program. Now, let's assume that our part origin is here. Our part origin is here. It means that you are going to use a workpiece coded system. Workpiece coded system. So we can start our program. For those people who are using controller, you see these CNC machines have different formats, but the program can be either ISO or depend on the controller. Like if you're using Siemens, the controller, the program is different, the sequence is different. You're using what you call Fanuc, you're using Has, you're using GSK, or you're using Sage Star. All these operate using ISO program, but the challenge comes when you are setting your part origin and also the structure, the format of the part program. A simple example is, for example, this part, you can say, this being a part origin, you can say this point 1, point 2, point 3, point 4, point 5, point 6, and point 7. Why am I using points? Because CNC machine can use point-to-point programming or contour programming. Contour programming meaning a continuous path. So if you form points from here, it becomes easier for you to transform into a Cartesian system or the coded system so that you understand how you're going to write the program. Let's say now this is program number 1, 2, 3, 4. Our tool number is number 1. If you're using Siemens, write T01, a tool number, and tool offset. We can actualize that we're using M03, the speedometer, with a speed of 2000, with a feed rate of M0.4 spindle per revolution. We say put on the coolant. Then we can say that our machine is at this position. G00 is like we are positioning our tool without cutting. That's rapid interpolation without cutting. Then our safety, assuming the work is 80, we can say that's 82, and Z is 10. That is safety. From there, I'm going directly to use a simplified part program, simplified code called a simplified program. We can say that now G71. G71 is stock removal along Z-axis. How does it operate? You have a workpiece. The tool comes, it plunges into material, and it moves along Z-axis, retracts, goes back, comes again, bit by bit, removing the material until you get the final product. Now let's say this N40, G71, U1, R1, then our N41, and N41 can be G71. This is a syntax for Siemens 71. You can use P, let's say our P is 42, Q is 45, Q is 45. We have what else? Then you can also have U 0.5, you can have W 0.1, and then we can also put our finishing speed M03, S 2000, and F 0.3. This will entail that the machine is going to use this speed for finishing, so that the part becomes smooth. If you're using the same tool, you increase the speed and you reduce the feed rate. Remember, the feed rate here was 0.4, but now is 0.3. And again, what does it mean by using G71? I've said G71 is stock removal along Z-axis, and then U1 is the U1 is the roughing in feed. Then R1 is retraction from the workpiece. P denotes where you are starting to cut. That's for the cane cycle. Then Q where you are ending to cut for the cane cycle. Then U 0.5 is positive, which means that it's external turning, which entails that you're cutting at 0.5 millimeter depth in feed for finishing. Then 0.1 is in feed finishing along Z-axis. This one is in feed finishing along what? X-axis. Now we actualize our finishing speed that we increase our speed and then we reduce our fit rate. From there, we can say that because our workpiece is here, we can say because we are using only linear, we use G01. Again, G01. Our X, we can say our X is 40. Our Z is 0. We put on X 50. Z, I'm using absolute programming. Z is minus 40. Minus showing the direction the tool is going because I'm using workpiece coordinate system and absolute part programming, diameter part programming. Then next you go to X is 60, Z is minus 40. Remember here, this one and this one is at the same, so I can ignore writing this one because the tool will assume is at the same point, which is Z is minus 60 and X is 80, Z is minus 60. And then the last point, which is now our Q here, I can say now N45, Q, not Q, G01, sorry, X is now 80, then Z is minus 80. So this is what we call the cutting program. From this point, what we call the cutting program, because a cutting program consists of 3 parts. Number one, the safety approach, the cutting program, and the safety retraction. So the safety approach is here. This is safety approach. This is the cutting program. Now, at the end of it, once you finish cutting, you need to retract your tool. How do you retract your tool? If you're doing external turning, retraction of your tool, you have to start with X first. I'm explaining this so that you understand what it means. When you use this triangle, a right angle triangle, this is the hypotenuse. The machine, if you use G00, X100, and Z100, the machine will use the shortest route, and it means that it will approach the safe point using what? The hypotenuse. But if you use G00, X100, and then Z100 as a next block, the machine will use this route. It will go to X first, then it will go to Z axis. That's how you approach. You retract the tool from the workpiece. And now, because I've also finished cutting, if I want to do finishing, I can include my code here, G70 for finishing, and then I can put P. Where was I starting cutting from? P42. Where was I ending? Q42. This will mean that my program at the end of it cutting, it will do a finishing cut so that it remove 0.1, 0.5 and 0.1 millimeter. And again, now I remove my tool, G00, X100, then I say Z100, then M05, M09, M30. Sometimes you can ignore writing M05 and M30 and use and M09 and use what? M30. It means that M30 will stop the spindle, will stop the coolant, and it will wind the program the start. Welcome to CNC experts. Here is core maintenance. We are glad to teach you more. This is just a little bit to quench your thirst. Hey.
Tool yako lazima ikue inaweza kama ni anti-clockwise lazima ujue hiyo tool itaweza take hiyo spindle and hiyo movement. So after that, finya press cycle starts. So
Yeah, yourself. Record where they are what are doing or ending.
I think that